Welcome to VKT, and today we will be talking about unit dimension and error. So let's start with some values. You need to learn some. Well, this chapter comes under most easiest chapter under physics, but if you don't know some values, you will be getting lots of problems. You will be losing marks from this chapter. So 1 parsec is equals to 3.26 light years. 1 barn is equals to 10 to the power minus 28 meter square. 1 sec is equals to 10 to the power minus 8 second. 1 light year equals 9.45 into 10 to the power 15 meter. 1 astronomical unit equals 1.5 into 10 to the power 11 meter. This much you must know under some values. Now to find on some dimensions, it is easier if you learn some values. Force, which is the most important, MLT minus 2, and then you must know on voltage 2, minus 1, 2, minus 3. You can find current, resistance from this using this relation, and others pressure, energy from this by using the formula and putting the dimension value. Now in case of when there is gradient means divide by L in dimensions. There are some values like to find dimension, E square is your HC. This is dimensionless. And then we have 1 root under mu naught epsilon naught. This is dimension of velocity meter per second unit, and from this you can find dimension. Linear and angular momentum. Linear momentum, mass into velocity, and then angular momentum. Angular momentum you will have into V into R, and linear momentum into R. From this you can find dimensions. There are some cases when you have to find inductance, capacitance. Then you can use the relation L by R is equals to root under LC is equals to CR is equals to T. This is the dimension, C into R dimension T. And R dimension you can find from using this. You need to learn some dimension of constants. So let's starting with Planck's constant. Planck's constant E is equals to hf. Energy, frequency, and then you can find Planck's constant. Solar constant E by area into T. Solar constant is equals to energy by area into time. Then we have Boltzmann's constant, K is equals to R by N. Resistance per mole, where is resistance? From here you can find P is equals to IR, and then you will find R, and then divide by mole, per mole, Boltzmann constant. Then finally Rydberg constant. Rydberg constant is nothing but equals to wave number, which is equals to L minus 1. And there is one more thing, Boltzmann constant is equals to entropy, thermal capacity, Planck's constant, solar constant, Boltzmann constant, Rydberg constant, L-1, Rydberg constant L-1. Now let's discuss on error cases. For error you have to know something on significant figures, and then there is next thing, rounding off. So let's discuss directly with questions. So here is a case. Percentage error in measurement of mass and speed are 2% and 3% respectively. Maximum error in kinetic energy. So formula for kinetic energy is half mv square. So error is given for mass and velocity. This is multiplication case with power. So in multiplication case with power, we have to add the change in energy by energy is equals to mass, change in mass by m plus power multiplied, then change in V by V. From here we found that change in m is 2% and change in V is 3%. So it will be 2 plus 2 into 3. It will be 2 plus 6, it will be 8%. So this will be 8% maximum error. Did you get it? This is in percentage case. If you are still confused, then write this formula, then del E by E, del M by M, del V by V, then power should be multiplied, and then you have to multiply 100% into 100 into 100. Then percentage is given 3%, percentage is given 2%, and then you will solve, you will get 8%, which is the required maximum error in kinetic energy. So summing up, we have the formula error percent, which goes to power change in 1 multiplied by percentage change plus power change in another into percentage change. So now let's discuss another case, length and breadth of rectangular sheet are 16.2 centimeter and 10.1 centimeter respectively. Area of sheet in appropriate significant figures. Figures and error is A 164 plus minus 3 centimeter square, B 163.62 plus minus 2.6 centimeter square, C 163.6 plus minus 2.6 centimeter square, and D 1.163.62 plus minus 3 centimeter square. So we know area is equal to length into breadth. Simple. So just multiply these to 162 into 10.1. You will get 163.62. But the significant figure here and here 3 3. So you should take only 3 significant figures, that is 163. But you have to do the rounding off, so here is 6, so 1 will be added here, it will be 164. This is the answer for first case. Now for error, delta A by A is equals to delta L by L plus no power, so delta B by B, it will be delta L by L, delta L is 0.1. Error should not be error should be same digit as last, so it will be if it had been 2 then it will be 0.002. So 0.1 by L is 16.2 plus 0.1 by 10.1. So if you cross multiply, it will be 1.01 plus 1.62 by 16.2 into 10.1. So now let's do it here. Now delta A by A is equals to 1.01 plus 1.62 by 16.2 into 10.1. Area is equals to this, so it will be cross. Then delta A is equals to, if you add this you will get 2.63, but 0.1 in question. This is the error, and there is significant figure is 1. Significant figure is only 1. So you have to make here significant 1. So if you round off, it will go 3. So the required answer is 164 plus minus 3. 164 plus minus 3. Where is the answer? 164 plus minus 3. So this is the required answer. Well, this is for multiplication cases. For addition and subtraction, you have to add, for example, x plus 2y. You have to find the value of z is equal to x plus 2y. Then what will do? Delta z by z is equal to delta x by x plus 2 into delta y by y. Sorry, for addition you don't need this, only upper part. If it was z is equal to delta x minus 2y, then your error delta z will be delta x plus 2 into delta y. You have to add same for addition and subtraction. Error will be added. Keep tuned for more videos.